Okay guys, we're going to go ahead and start our math segment. Could someone with a nice loud voice read the learning target? Gary, with a nice loud voice.
To compare fractions with the same numerator pictorially.
Ooh, you said it correctly, pictorially. So I can compare fractions. So how do we compare fractions? Using what?
Number line.
We can use number lines, but we can use our symbols. Same with the greater than, less than, or equal to, or same. So we're going to compare fractions with the same numerator. Is the numerator at the top of the fraction or the bottom?
Top.
The top. And then it says pictorially. Raise your hand if you know what that means.
I have no idea.
Pictorially. Do you have an idea?
Pick carefully.
Good idea.
Equally.
Good idea.
Picture.
Pictures. Pictorially. So we're going to draw pictures to represent fractions. Okay. So I need everyone to flip to side A of your fluency.
Where is it?
Okay. Okay. On your mark. Get set. Go. Okay, guys. 10.
Yes.
0.
Yes.
20.
Yes.
1.
Yes.
11.
Yes.
31.
Yes.
2.
Yes.
12.
Yes.
42.
Yes.
3.
Yes.
13.
Yes.
63.
Yes.
4.
Yes.
14.
Yes.
74.
Yes.
5.
Yes.
15.
Yes.
75.
Yes.
6.
Yes.
16.
Yes.
26.
Yes.
46.
Yes.
66.
Yes.
7.
Yes.
17.
Yes.
27.
Yes.
77.
Yes.
57.
Yes.
8.
Yes.
18.
Yes.
28.
Yes.
88.
Yes.
68.
Yes.
9. 19. All right, give those a round of applause. Who was able to finish? Good deal. So write how many you wrote correct at the top, and then write a goal for the next side. Okay, after you've done that, flip over to side B. Okay, everyone should be on side B. On your mark, get set, go. And that cover up your nose, sir. Thank 14.
Yes.
44.
Yes.
5.
Yes.
15.
Yes.
85.
Yes.
6.
Yes.
16.
Yes.
26.
Yes.
66.
Yes.
86.
Yes.
7.
Yes.
17.
Yes.
27.
Yes.
87.
Yes.
67.
Yes.
8.
Yes.
18.
Yes.
28.
Yes.
58. Ooh, round of applause for those, guys. Good job. Okay, go ahead and close your fluency, or put it away. And we're going to get started with our fluency for our lesson. So everyone, open up your journal, and then once you're done that, open up here, please. Open up your journal. You may use the back of pages now. Alright guys, on the count of 3, I want you to say the fraction that is shaded. 1, 2, 3.
1/2.
Awesome. So how many fourths do I need to shade to equal 1/2? I want you to write the fraction in your journal. Jacoby, can you go up there and draw fourths on our model? Everyone look up there at Jacoby. So he's splitting our halves again to make fourths. So after he did that, everybody on the count of 3, how many fourths do we need to shade to equal 1/2? 1, 2, 3. 2 fourths. Thanks, dude. On the count of 3, I want you to say the fraction that is shaded. 1, 2, 3. 1/3. Same thing, guys. How can we turn our thirds into ninths? And how many ninths will be shaded? I want you to write it in your journal, and I'll pick somebody as I come around to go turn the thirds into ninths. I'm going to pick a girl. I'm going to pick a girl, so you got to show me that you know how to do it. Ooh, Cameron, you're looking good. You can go up there, Cameron. Everyone check and make sure. I want you to check and make sure yours matches Cameron's. Oh, look, guys, she's partitioning the thirds into thirds again. So let's count them together to make sure she did it right. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Give it a second.
Oh. Someone has to. An obstacle or no.
Alright, there we go. So we have 9 parts now. So did she partition them correctly?
Yes.
Absolutely. So on the count of 3, I want you to say the shaded number of ninths, okay? 1, 2, 3. 3 ninths. Awesome job. So now, on the count of 3, I want you to say the shaded fraction. I'll give you a second to count that. Say the shaded fraction on the count of 3. 1, 2, 3.
6.
Good job. Ooh, don't let it trick you guys. How many fourths? Oh, so the other ones we were partitioning the whole into more pieces. Now we're trying to go back. How many fourths is equal to 6 eighths? It's kind of tricky.
Oh no.
Show me in your journal, and I'll come around and pick somebody. How many fourths would be equal to 6 eighths? between the numbers. So if you don't get it, Jose, we're going to watch the front and let's see what he does. Okay. So he thinks that there should be 3/4. Will you write that fraction for us instead of just 3? 3/4.
Oh.
That's okay. So I'm going to stop him right there. Does he have to draw a model?
No.
No. Thank you so much, dude. So let's look at the relation between 3/4 and 6/8. Raise your hand if you notice a relation. Jacoby, what do you notice, dude?
That 3 is half of 6 and 4 is half of 8.
Oh, does everyone see that?
Yeah.
If you divide 6 by 2, you get 3. If you divide 8 by 2, you get 4. Now let's look at the opposite. 3 times 2 is 6, and then 4 times 2 is 8. Does everyone see that? So did you have to draw out a model to get 3/4? No. You just had to look at the relationship between the numbers. Okay, let's keep going. All right, I want everyone to close your journal. Open up to your application problem. Just like we do every day, I'm going to read it aloud. And you guys read it silently to yourself. And you'll have 5 minutes to complete this application problem. Latanya has 2 equal-sized hot dogs. She cut the first one into thirds at lunch. Later, she cut the second hot dog to make double the number of pieces. First, I want you to draw a model of Latanya's hot dogs. Part A, how many pieces is the second hot dog cut into? Part B, if she wants to eat 2/3 of the second hot dog, how many pieces should she eat? Okay, I'll read it again. Latanya has 2 equal-sized hot dogs. She cut the first one into thirds at lunch. Later, she cut the second hot dog to make double the number of pieces. Draw a model of Latanya's hot dogs. Part A. How many pieces is the second hot dog cut into? Part B. If she wants to eat 2/3 of the second hot dog, how many pieces should she eat? You have about 3 more minutes to work individually. This is correct. She cut the first one into thirds. Well, the second one is cut one more time, so it's going to make double the number of pieces. So you double that one. How can you double this section? So it's not pieces. 1, 2, 3 in this one. You should double the amount of pieces. 1, 2, 3, 4, 5, 6. We drew a model. How many pieces is the second dog cut into? Hot dog cut into? This time. 1, 2, 3, 4. Awesome. So let's look at it. She wants to eat 2/3 of the second hot dog. How many pieces should she eat? Make it easier drawing model again. Draw your own way. And show them how. 1/3 of it. Show them 2/3 of it. Weston, dude, can you go up there and draw the 2 models? Just draw the 2 models. Yes. Think about it. Yes. Think about it. He drew little tubes. They look like hot dogs. If you drew rectangles, like off to the side. So just like Weston did, we know that the first one was cut into thirds. So he went ahead and cut the first hot dog, or partitioned it, into thirds. So let's take a look at what Weston did. He split up the pieces one more time. And how many pieces did that give us, Vanna?
6.
6. So what is the answer to part A, Vanna?
He cut the second hot dog into 6.
6 pieces. So for A, give me a thumbs up if you got 6 pieces. Awesome, awesome, awesome. Good deal. Okay. So Weston went ahead and shaded in 2/3 of the first hot dog. But the question asks, if she wants to eat 2/3 of the second hot dog, how many pieces should she eat? We know that the second hot dog, what is it partitioned into, everyone? 6. So we have to figure out how to convert 2/3 into 6. We gotta find the equivalent fraction. 2/3. What would it be, Kai? 4/6. Is he correct, everyone?
Yes.
All right, well, let's count the pieces just to make sure. Thank you so much, Weston. You're awesome. So we have 1, 2, 3, 4. Is Kai right?
Yep.
Absolutely. So our answers are 6 pieces and 4, 6. So she should eat how many pieces, everyone? 4 pieces. Any questions about this application problem? Any questions? Don't you see how it's easy to draw pictures and to find your answers from the pictures? Absolutely. So let's go back to our learning target. I can compare fractions with the same numerator pictorially. Didn't we draw a picture to help us out? Absolutely. Okay, so let's go to the next slide to see if we were correct. So there's the model, split into thirds and then into 6. They shaded in 2/3, they aligned it up with the second model, and they had 4 pieces shaded in. So were we correct? Absolutely. Oh, so now keep your application problems looked at. I ask you to look again at your models of LaTanya's hot dogs. Oh, it's going to throw in a challenge, everybody. Let's change the problem slightly. What if LaTanya eats 2 pieces of each hot dog? So let's draw it out. Here's our first model. What was it split into, everybody? Thirds. Here's our second hot dog. What was it split into, everybody? 6. 1, 2, 3, 4, 5 lines make 6. Well, what if LaTanya eats 2 pieces of each hot dog? Just pieces. Okay. Figure out what fraction of each hot dog she eats. So we know that the numerator is the same because it's just 2 pieces, but is our denominator the same?
No.
Ooh, what's the denominator for this one, everyone?
Thirds.
Gary, what's the denominator for this one? 6. Uh-oh. 1 second. Thank you guys for helping me out. You guys are awesome. So let's take a look. Were we right? 2/3 and 2/6? Did LaTanya eat the same amount of the first hot dog and the second hot dog?
No.
Whoa, no. How come? Raise your hand. Raise your hand. Vanna, why not?
Because the third has bigger pieces.
Oh. Is she right, everyone? Give me a thumbs up if she's right. Absolutely. Aria, you want to add something? No. No, you think the same thing? You're absolutely right. The pieces in the thirds are larger than the pieces in the sixths. You want to add something?
Yeah, 2/6 is equal to 1/3.
Oh, she said that 2/6 is equal to 1/3. So if we just shaded in one piece over here, then would she have eaten the same amount?
Yep.
Yes, but the problem didn't ask that. It's asking why is the amount she ate different? And Vanna gave us the explanation because the sizes of the parts are different. Okay? Any questions about that? No. Good deal. Let's move on. So everyone flip open your journal again. I want you to draw 2 pizzas. 2 circles. That makes me hungry for lunch. What about you guys? So after you have flipped open your journal and you have drawn the 2 circles, I want you to partition both of the circles into fourths. Partition each of the pizzas into fourths. Give me a thumbs up what you've done. I'm looking for everybody's thumbs so I know to move on. Good deal, good deal. I'm missing some thumbs over here.
Oh, I have none.
Good. All right, let's move on. So the first pizza, you're going to keep it into fourths. Don't touch it. But the second pizza, it wants you to double the number of units.
6.
So if it's fourths, what would be double of fourths? 8. So change the fourths into eighths on your second pizza. Awesome job, Jose. Will you show that around so everyone can see what it looks like? How did you change it from fourths into eighths? What did you do? How many more lines did you draw? You drew 2 more lines, right? All the way through? Awesome. So we have fourths. What's the units in the second one, everybody?
8.
Eighths. Awesome. So I want you to shade in 3/4 and 3/8. 3/4 and then 3/8.
What's wrong with it?
So after you've done that, I want you to think. Everyone put your finger to your head. Let's think. Your thinking finger up to your head. What shaded portion would you rather eat if you were really hungry?
3/4.
If you were really hungry, would it be the fourths or the eighths?
4.
Show me fourths on your fingers if you'd rather eat the fourths, and then show me eighths if you would rather eat the eighths. Imagine that you were super hungry. So everyone's saying fourths. Raise your hand and tell me why. Stella, why?
Because they're bigger numbers because even though the 8 is a larger number, it has smaller pieces.
But
And
I have a question. The numerators are the same. You get 3 pieces of each. You get 3 pieces of each.
oh,
Cameron, what am I missing?
you are missing that the 8 is separated into more parts, which makes it smaller. So the thirds are bigger.
Did you guys hear that?
The fourths are bigger.
Even though I'm still going to eat 3 pieces of each, she said that the pieces in the fourths are larger. Do you guys see that? These pieces are larger than over here. These pieces are smaller. Oh, okay. So both choices are 3 pieces. And she told us that they're not equivalent because they're smaller. The eighths are smaller.
The whole is equivalent, but the fractions
The pieces are different. Absolutely. So let's move on. So now we're going to play a game, but first we got to listen to the instructions. Partner A, so there's going to be 2 partners. Partner A, they're going to draw a hole and shade a fraction. So they would draw a hole, whether it's circle, rectangle, square. They're going to draw a hole, okay?
don't matter.
And then they're going to shade in a fraction of it. Well, I'm going to split my hole into thirds, and I'm going to shade in a fraction of it. And then I'm going to label it. That's what I'm going to do as partner A. Well, let's pretend that Michaela is my partner. same number of shaded parts, but choose a different fractional unit. So we have the same whole. Same number of parts. They're going to choose a different fractional unit. In partner A, you're going to check your friend's work to be sure that the fraction is less than yours. And then you're going to say if it's less than or greater than when comparing your fractions. Okay? So I'm partner A. I drew a hole, I partitioned it, and then shaded into parts. Then I also labeled it, okay? And then partner B, you're going to draw the same hole. You're going to partition it into the same number of parts, but you're going to shade in a fraction that is less than. Okay? And then you're going to look at them together, and partner A is going to decide if that fraction is less than or greater than. Okay? I'm going to allow you to choose one partner. Everybody's here. So everyone can choose one partner. Are there any questions about what you're going to be doing? No. You're going to do all of this inside of your journal, okay?
So when you do it on
In your journal. Okay, everyone pick a partner quickly, and then you can start your game.
Me and Ethan are always playing. Very full.
Awesome. Good deal.
Very
Diana, do you need a partner? All right, you're with Maddie. Chase, who are you with?
Toby.
Oh, you want to put any partners? Awesome. Good deal. You guys work together. You need a partner, baby? What do you think about Hey, Dawson.
Are you making a circle? I'm making a hexagon. 5 sides. One side, 5 corners.
Partition it.
That's a pentagon.
Now shade in. This one then shade in a fraction. Okay, now label it. What is your fraction that you're shading in?
8. That's a...
Okay, awesome.
Learning, you don't have to make a
So now you're going to draw one that is less than. Yes. So you have to draw the same hole and then the same number.
Not 2.
Just 3. Alrighty, so partner A, check this. I want you to say, is this fraction greater than or less than here?
You don't have to do all of them. So like this.
Greater than or
Keep this.
less than. Awesome. Now draw another. Keep going. Now draw another hole and partition it into different parts.
It's the same hole, but you should 5 or 8 and greater than
Okay guys, we're going to give you 2 more minutes to keep doing this, and then we'll come back together.
Okay, I'm not going to do this.
Alright, now do another one. Maybe not so many Oh, y'all did a lot of fun. Oh my goodness. So now are you doing something?
I'll do like
I want to watch this. So now you're going to do
this first. Are you going to do this
Oh, y'all are doing great. Awesome. Okay, guys, everyone go back to your seat. Alright, everyone go back to your seat. Back to your seat. So thinking about the target, I want you to raise your hand and tell me why you think we did that game. Why do you think we did that game, Weston? Thinking about the target.
To learn how to tell which one's less or greater.
Ooh, and look at the target. What's the word for showing greater than or less than?
I forgot.
Look at the target. What do you think? Didn't we compare fractions by determining if they were greater than or less than? Yes. And didn't we see the pictures? Yes, absolutely. So I want Gary and Kai to come up here. Partner A, I want you to draw your hole right here. Partner B, I want you to draw your hole right there. And then right in the middle, if they were less than or greater than. Everyone look up there. Okay, so they're both two holes. Good deal. Okay, so is 2/4 greater than or less than 1/4?
Greater.
Greater than? So now I have a question. What if I drew Kai's 1/4? I shaded it in. Now let's say that I split this one into 6, but I still shaded in one part. Would 1/4 be greater than or less than 1/6? Greater than. But the numerator's the same. It's still one part.
Because
How come 1/4 is greater than, Kai?
Because the piece is bigger and each time you go a higher fraction, the size decreases.
So you're telling me that even though the numerator is the same, the denominator, or how many parts there are, determines if it's greater than or less than. So we know that 1/4 is greater than because the parts are bigger, right?
Yeah.
You want to add something, Michaela? Oh, sorry, my bad. I meant to do 8s. Thank you. Okay. So let's go back to our learning target one more time. I can compare fractions. Did we compare these fractions?
Yes.
Yes. With the same numerator. Do these two have the same numerator? Pictorially. Did I draw a picture?
Yeah.
So are we doing the learning target? Absolutely. Let's go on to our problem set. Show me on your hands if you're feeling like a 1, 2, 3, 4, or 5 on this learning target. So keep your hand up if you're feeling like a 5. Put your hand down if you're not a 5. So I want you to look around to those who are 5s. And while you're completing your problem set, I want you to go to those friends if you need help, okay? Alright, so everyone flip over to your problem set and start your problem set, okay? If you're feeling like a 1 or a 2, I want you to come up to the carpet with me, okay? If you're feeling like a 1 or 2, you can come up to the carpet and work with Miss Bell. You can go and sit around there. Hey Gary, can you go press stop on the recording?